Hello guys, welcome back to my channel. It's been a long time that I've come here, so I'm come back with something nice, and this is a overview of API protocols, how to use it, when to use it, and which one to use it. I hope you find this useful. More details coming up, and of course you can find the link to the source code, GitHub repository, and the steps to deploy it inside description. Check below, and let's get started. Thank you. Most engineers pick the wrong API protocol. They have no idea they're doing it because the question they're asking is which one is best. The question doesn't have an answer. This is like asking which one is best, a postcard, a phone call, or shouting across the room. They're all best, but they are best at different things. In next few minutes, I'm going to show you how to choose the best API protocol for your use case, and I'm going to deploy one sample app. It's a backend, a small backend for a online shopping e-commerce website, and it's just created for demo and deployed on AWS, and you will see it towards the end of this video. Meanwhile, let's do a quick reset because we all have used APIs in some form or the other, but let's do a quick reset, and I'm going to explain you in detail with an example what is API, the REST API, GraphQL, and gRPC protocols. They have common things as well as they are different. So basically, when two pieces of software talk to each other across a network, they need to agree on three things. They need to agree on what the message looks like. Is it text? You can read it. Or is it packed down with bytes? They need to agree on what carries it, what kind of network connection, and they need to agree on the shape of conversation. Am I asking for a thing, or am I telling you to do a thing, or am I sending you a big list of what I want? So pick a different answer for each of these three things, and then you get a different protocol. So it could be REST, GraphQL, or gRPC. These are the popular set of answers, and of course there isn't a best choice. It's all the choice that we make for a particular use case. Moving on, here is a small overview on the pros and cons of each. I will help you understand. Let's take an example of a restaurant and imagine yourself as the REST API for this first scenario. So if you are a REST API protocol and then you walk up to the counter and you say one coffee, one croissant, somebody hands them to you. It's clean, simple, everybody in the world knows how to do it. And the downside of this is if you want 6 different things, you have to walk up to the counter 6 times. So that's how a REST API works. Whereas GraphQL is when you sit at a table and you tell the waiter all the things that you want, everything at once, like croissant, eggs, juice, and the bill at the end of your transaction. Then that's one conversation. The waiter goes off and assembles everything on a tray and then brings it back to you. And the waiter has to be good, otherwise if they are sloppy, they'll have to make maybe 12 trips to the kitchen instead of one. Now these are where external user wants to interact with a system. You use REST API or GraphQL, whereas gRPC happens something within the system. So we have to go deeper now inside the kitchen for this analogy, and imagine there are a bunch of cooks in the kitchen and preparing different things. They might be talking about in a fast, and no, they don't want to waste time, and they do all this probably using some sort of a shorthand, and they are standing 5 feet apart and then trying to shout at each other. So this is like a chaotic situation which we are as a customer not aware of what's happening inside the kitchen. So 3 different conversations happening here, 3 different jobs, and now you know which one is used for what. So let's consider a flow of an order. When you place an order as a customer, or if you want to check some dashboards if you're a seller, and then how the internal services talk among themselves. So let's make it concrete. I have built an e-commerce backend. Let's call it order flow. It does what most real systems do. A customer on their phone places an order. That's the person at the counter. They need simple public way to order. And then comes the merchant on their laptop, opens a dashboard that shows the order, who placed it, what's in it, and the price, the fraudulent transaction check, everything in one screen. That's the customer at the table getting the whole meal. Remember that from the restaurant analogy? And then inside the system, 3 little microservices, they have to talk to each other constantly. One checks if the item is in stock, the second one calculates the price, and the third one scores it for a fraud. These are all cooks in the kitchen. So 3 jobs, 3 conversations again, and then each one wants a different protocol. Now, moving on. This is a picture I want you to remember. I'm going to show you this in a much detailed way. So look at the top layer, the public edge. Anyone with an internet connection can reach it. This is where REST protocol belongs. Plain JSON over HTTPS, cacheable, debuggable with curl, and this is representing the customer at the counter. Then moving on, the middle layer is where the dashboards talks to the backend. One screen, lot of data, mobile network probably, and this is where GraphQL belongs. The waiter from our analogy, and he's taking order in one conversation. He's getting a list of things that he has to go around and then bring it back together and serve it to the user in one go. And the most bottom layer is where services inside your network talk to each other. Same building, same VPC in this case, because I've deployed this solution on AWS, and there's the same trust boundary, and this is where gRPC belongs. So each protocol sits in a layer where its strengths matter and its weaknesses don't. And that's what I meant when I said you have to pick the right choice for your use case. Sorry, this is the next portion of the solution. So here is what's interesting. When a customer places an order, the order arrives at the public REST API, but the REST API cannot actually fulfill the order by itself. It needs the kitchen. So in this case, it's the backend. So it does something subtle, and it speaks to the REST to the customer outside in plain JSON, meaning if a customer is placing an order, he gets a confirmation back on his mobile device or a browser. He gets the response back in JSON format, the same format which he was talking to with the API. And it's a slow lane, agreed, but it doesn't cause much problem as long as it's in acceptable limits. And then it speaks with the backend in gRPC to 3 services inside, and each services within each among themselves, they talk to each other via gRPC protocol. So basically that's how real systems work, and protocols aren't fighting each other. They are basically handing off the responsibilities to each other wherever there is a best fit. So you may wonder, why do we need and how do we arrive at this decision? So here is a nice flowchart. Let me go back to the right page. So this is more like a decision tree where you can check, like if you're designing a new endpoint, you have to ask yourself 3 things in order. Are you inside the backend? Then the answer is gRPC. If you are somewhere in the middle layer taking orders for complex queries, then GraphQL could be a right choice, and if you are at the edge layer, meaning talking to external interfaces, then good idea to proceed with API. Now I would like to show you the architectural design, because enough of PowerPoint. Here is what it looks like in implementation. So on AWS side, I have used CloudFront, which is customer facing. So a customer on his mobile browser app could access the CloudFront distribution URL, and then at the top you have two distributions. The second one is for the merchant. In this case, if the merchant wants to access his dashboard to populate several other details, then he can use the second CloudFront. And there are two flavors of API gateway. The older one in front of REST, and the newer, cheaper one is in front of GraphQL. I used the lighter product where I could and the heavier one where I needed its features, and that's the real trade-off that you have to make. And now coming to the middle layer, where there's a bunch of lambdas operating within the VPC. Both lambdas live inside private subnets, and there is a real trade-off here, because lambdas usually live outside VPCs where they need to start off faster, and that way these lambdas have to talk to the kitchen. Coming back to the analogy, this only exists within the VPC, so I put them inside and paid for it. The first time a lambda runs after being idle, it needs a second to introduce itself to the network. So for this demo it's fine, but for a real product where first user will wait, and then I would probably add a provision concurrency to keep a lambda warm. But in this demo that's okay. And there's an internal load balancer in front of the backend, which is communicating via gRPC protocol, not the HTTP. Two specific settings here. The protocol version is gRPC on the target group, and the gRPC aware health check that looks for a status code 0. So if you forget either one, the load balancer will fail and it will fall back to HTTP. And the backend services don't respond the way it expects, and every connection dies with an error that looks like a network problem. So people might lose half a day. So that was a good find while troubleshooting this, and when I was trying to make it. And for example, there is a bunch of VPC endpoints for Dynamo, and the ECR repository for my Docker image where the actual application resides. And I've used a static website to deploy it to S3. And let me check if I can bring up the screen. I can also showcase the AWS side of things. Yes, I've deployed everything in EU Central 1 region, and these are my APIs. This is the REST API, which has got these usual methods, and then I have these CloudFront distribution, and this is my ECR container registry, which has Docker images for my application. This gets deployed to my ECS cluster. I've got 3 tasks for each microservice, and 3 services basically, and each service is one is for fraud, one is for inventory check, the other one is the pricing calculator, and then I have a bunch of lambdas, and then the usual monitoring, logging, and the application also generates traces, and I'm capturing them in the X-ray, the AWS service, the AWS native service. And here is the internal load balancer. It is the internal one, and this is deployed in EU Central 1. So nothing fancy. Coming back to the demo, I can take you to the browser. Let me make it big so that it is visible. So here I will do a hard refresh. Alright, so now for example I go ahead and place an order via REST API. I could put in some dummy details, and once I place, I would get some response. And now this was done from a customer's point of view. It could be accessed even via a mobile application. Now for example, a merchant decides to check his dashboard. What is the status of an order? Is it shipped? Is it a fraudulent? And what is the fulfillment status? So if he loads it via REST API, because here we are trying to compare what's the performance of REST API versus a GraphQL. So here it makes 4 calls and it takes about 329 milliseconds, and then it takes 4 requests. But what if we use GraphQL? Let's see. So it's gonna make 1 request, and it has taken almost 9 if not 10 times longer, and we get a huge payload out of at the end of this successful request. Now we can also check the value of GraphQL and n+1. How does it differ from that? So obviously you can see what's the performance. There is a huge difference, and this would matter when you need low latency application and you would need a good performance out of your infrastructure. Imagine not doing a demo, but imagine doing this during a peak sale season or a Black Friday event. So there you cannot let down your infrastructure, because if you do that you would lose your customers. So going back to the design, let me bring that window up. Alright, so here coming back to this decision tree. So if you need a new API, I would ask these questions and then I would probably arrive. So if you are gonna sit inside the VPC and share the network with another service, so then if it is yes, the answer is quite easy, we go with gPRC. If my answer is no, then does one of the screen needs data from many sources? Yes, then I would go for GraphQL. And if I just have a one-on-one query, then I would go with the REST API. Also, if the request is cacheable, I would definitely go with a REST API. So these is a very simple decision tree that I would employ, and then get my answer quickly within less than 10 seconds. This could be a very useful takeaway when designing complex systems where we have a lot of interdependency as among services. We have both internal as well as external consumers of our backend. So I have a question to ask. If you're going to design a new endpoint this week or the next week and you sit down to do it, what will be your first instinct? Will you try to copy the protocol from your last endpoint that you built, or are you going to follow this approach? I'm curious to know. And as always, I would request you, if you found it useful, or if not, please share some feedback where I can improve. And if you can share, like, or subscribe to my channel, that would be a nice encouragement to me to continue building more AWS or cloud related videos. Thank you. Have a good week.